Our problem is question 1 from the 2015 AP test, and a calculator is allowed. This problem is one of the more difficult free response questions of the 2015 test. The mean score was 3.42 out of 9 points, ranging from 0.92 points to 5.92 points with standard deviation.
Number 1. The rate at which rainwater flows into a drain pipe is modeled by the function r, where r of t is equal to 20 sine of t squared over 35 cubic feet per hour. T is measured in hours and goes from 0 to 8. The pipe is partially blocked, allowing water to drain out of the other end of the pipe at a rate modeled by d of t equals negative 0.04 t to the third plus 0.4 t squared plus 0.96 t cubic feet per hour for t to 0 from 0 to 8. There are 30 cubic feet of water in the pipe at t equals 0.
Part A. How many cubic feet of rainwater flow into the pipe during the 8-hour time interval from 0 to 8? For part A, what we're going to want to do is we're going to want to set up the integral from 0 to 8 of the rate flowing in, which is given by r of t, which is given by 20 sine of t squared over 35 dt. We can do this with our calculators by making sure first to put it in radian mode, not degree mode, common error. Going to y equals, plugging in 20 sine of x squared over 35, zoom fit, second calc, go to 7, and go from 0 as your lower limit to 8 as your upper limit. And we get that the integral is about equivalent to 76.570 cubic feet. You get 1 point for the integral, and you get 1 point for your answer.
A common mistake in Part A is the student includes the initial condition. For Part B, the question asks, is the amount of water in the pipe increasing or decreasing at time t equals 3 hours? Give a reason for your answer. So we know that the amount of water in the pipe, A of t, is equal to the initial amount of water, 30, which is given in the problem at time equals 0, 30 plus the integral from 0 to t of r of x dx minus the integral from 0 to t of d of x dx. And this is the amount of water flowing in minus the amount of water draining. And so when you take the derivative of this, because of the second fundamental theorem of calculus, it's r of t minus d of t, which we are given in the problem above. And now we can use our calculator to find d of 3 and r of 3. So we're going to go second calc value at x equals 3, and this shows up with our first equation, which is our r of 3. And then we're going to go second quit, and then we're going to go alpha 1 to get our y value of 5.086. 3, and then we're going to store alpha a, and that is our value for r of 3 minus, and then once again we're going to go second calc 1 for the value x equals 3, and then you're going to hit your up button here to get to your second equation, and then we're going to go second quit alpha 1 to get the y value, which is what we're solving for, and then store alpha b. You can write 5.4 down, and then alpha a minus alpha b to get a, the derivative of a at the point 3 is equal to negative 0.3136, and the way you can solve this is simply looking at r of 3 and d of 3. And now we see that r of 3 is 5.0863 and D of 3 is 5.4. And if we know that the pipe is leaking more than the water that's flowing in, the amount of water in the pipe is decreasing. And so our reasoning is, since A prime of 3 is negative, the water in the pipe is decreasing. And then if we wanted to, we can mention negative, and we can put A prime of 3 is equal to negative 0.313. And so that is the explanation for solving, if you solved it with the derivative. And if you were just using R of 3 and D of 3 and comparing those two, you could say, since the rate at which the water is draining, or simply D of 3 is greater than the rate at which water is flowing in, the amount of water in the pipe is decreasing. And then in both situations, make sure you write at t equals 3. The explanation can be written more simply as, since D of 3 is greater than R of 3, instead of this long explanation that's written out. And the points you are given is to consider R of 3 and D of 3, which you get 1 point in this situation. You get 1 point for your answer and reason. Your reasoning is this since part, and then your answer is decreasing, and here's your since part, and your answer is decreasing. So that would be 1 point for a total of 2 points for part B.
Let's see. At what time from 0 to 8 is the amount of water in the pipe at a minimum? Justify your answer. The amount of water in the pipe is going to be dependent both on the rate flowing in and the rate flowing out. So we want to know what the zeros are of that overall function. So we need the rate flowing in minus the rate flowing out. So when is that equal to 0? Well, we again can use our calculator for this problem. So back to the equations we already have plugged in, we'll go ahead and turn those off. For this third equation, we will simply go into vars, y-vars, go into function, go y1, subtract variables, function, y2, let's just assume standard. Very clear to see the zeros of the function. The time will equal, well, clearly, let's calculate our zeros. Left bound, right bound. This one looks like it's at 0, 0, but just to be sure, yep. There's our first 0 in the time interval from 0 to 8. Secondly, we have this more obvious 0 over here to the right. Should be within our interval, looks like it. 3.272 when rounded. Now, all we need to do is figure out when each are minimum and maximums. So we can use a sign chart. You know our zeros, 3.272. And this 1 and 4 are both in between. We can also use our calculator to determine that below here it is negative. This is positive. This is above the x-axis, before 0, below the x-axis, in between these 2 points, and above the x-axis here. So we know that going from positive slopes to negative slopes, relative maximum, which means at the beginning there's a maximum, and at 3.272 there should be a minimum. All we need to do is give our explanation, because the overall rate of flow of water shifts from negative to positive at time t equals 3.272 hours, there is a relative minimum, which remember is what we are looking for, amount of water in the pipe at t equals 3.272 hours. Now, a little repetitive, but that should ensure that you get all three of the points for this section. The first point you get for considering that the overall rate considers both the rate flowing in and the rate flowing out, and that it should be equaling 0 at the minimum value. So you get 1 point for that. You get 1 point for your actual answer, that the relative minimum occurs at t equals 3.272 hours. And you get another point for your justification of that point.
A common mistake for part C is the students did not use the equation r of t minus d of t is equal to 0. The students also did not provide sufficient justification, which included the endpoints.
Part D. The pipe can hold 50 cubic feet of water before overflowing. For t is greater than 8, water continues to flow into and out of the pipe at the given rates until the pipe begins to overflow. Write but do not solve an equation involving one or more integrals that gives the time w when the pipe will begin to overflow. So we start out with 50 because it says right here, that's how much the pipe can hold before it overflows. And then the initial condition would be 30, which is right up here, which is given right at the beginning of the problem. And then we want to find the integral from 0 to w, because time w when the pipe will begin to overflow, and that's the time we want to stop. And then we have r of t, which is the rate of rainwater flowing in minus the rate of rainwater flowing out, d of t. And so the way you're scored, you get 1 point for this section right here, and then 1 point for the total section from here to here.
A common mistake for part D is a notation problem. Putting the initial condition after the integral means the integral is not well defined. Students should put the initial condition before the integral to make sure they are given the allotted points.